Hey, what's up YouTube? So here's my most recently assembled DC to DC white flashlight. It's entirely portable and was assembled from workbench components and spare parts I had on hand. The construction of the device here is comprised of this Defiant steel mill casing for a grip, and it's actually quite decent, and there's a lot of room in there to fit components. And this device is currently in a non-rechargeable state, but I could easily fit some lithium-ion batteries in here. And here I have the toggle switch for turning the device on and off. And that's secured using this rubber guard here. And here at the aperture I've mounted a standard Polaroid lens there I got from an old Polaroid camera. And it works well enough for torch or flashlight capabilities. Now I'll hit the switch, and as you can see we have a fairly bright and white LED flashlight there. Great for the outdoors at night, or if you're inside and your power goes out, this is a great convenience for just getting around. As you can see, it's quite bright. It's not overly intense. It's just enough, really. Now let's turn the lights off and see how capable this flashlight really is. Alright, so now I'm going to turn the lights off, but I'll leave this light on over here as a reference. And here I'll turn on the flashlight. So as you can see, it makes a pretty big difference in terms of lighting. Yeah, I would definitely trust this for outside purposes. Look at that, I'm drawing it back as far as I can and it still maintains its illumination there from the far field. Very well-rounded beam there. Alright, so now I'll go ahead and disassemble the device here and show you the internals. So here I've disassembled the flashlight to reveal all of the internal components, consisting of the battery pack, or the power supply, the driver right here, the toggle switch, and the white LED right here. So as for the power supply, it's quite simple. I'm using 3 PC alkaline AA batteries, and we can do a measurement test to indicate where the voltage is at. Alright, so here I've applied both probes to the power supply here. And as you can see, we have a voltage reading of 4.5 volts. Here I've switched the device on, and as you can see, we have a voltage drop down to 4.25 volts there. So essentially I have the positive end of the battery supply here connected to the toggle switch here. And then I have the other positive end of the switch here connected to the positive input pin to the semiconductor here. And I have the negative lead of the power supply connected directly to the LED here. So as for the circuit here, it's really quite simple. I'm using a LM317T adjustable voltage regulator for regulating the circuit here. And from the input to the adjustable pin, I have one wire for excess current. And from the adjustable pin to the positive output pin, I have a 22k ohm resistor acting as the load. And I also have a 100 ohm resistor as well as a 16 volt 220 microfarad electrolytic capacitor. Some of these external components here enhance the overall brightness of the white LED emission, with very little heat waste being produced as a result. Now I can reassemble all of the components back into the original housing here. What I want to make sure of is that the heatsink is well insulated with electrical tape so that it doesn't short out against the metal housing here during operation. Here's the convex optical lens. You can find a lot of these lenses in old Polaroid cameras. This flashlight can produce really cool diffraction effects.